My name is Gopi, so I'm going to be providing a demo software. So our software is a word guessing tool, and we make use of dependencies such as Flet, which provides the graphical user interface, request, which has our software with request at any time to download English words, a dictionary of English words. Word frequency allows our software to make frequently used English words. And so we start by importing the dependencies. Let random. Random allows our software to select words at random. Always allows us to do command line to access. And we create an object of our word guessing game. And these are the initial parameters that are going to be passed to the game when initialized. Our software provides two themes: dark theme and light theme. So I'm going to run a demo of our game so you see how it works. So the default interface for the software has a dark theme, and we begin by clicking on begin. Then we type random characters. I like to go with vowels first. So there are different color codes. Red means that the alphabet is not in the word at all. Green means that you got the alphabet correct and in the right position. And yellow means, well, the alphabet is in a word, but then you just placed it in the wrong position. So going forward, we are going to maintain the position of E. We are going to switch the position of I, and we are going to introduce new alphabets in the places of A, O, and U. So we got one more letter correct, T. So I'm going to switch B and S, and we can go on and on and on. We can give it a few more tries, and we're probably going to get the right word. So this is how our game runs.
Hello everyone, my name is Blessing Emmanuel. In this video, I'll briefly explain this part of our code. We first start with the download words function, which is responsible for generating the word list. So inside the try block, we import the top end list from the word freak library, and we request the top 550,000 English words using the top end list, and we pass the language that we are looking for and the total number of words that we want. So here, as we iterate through the top words that we got from the word freak library, each word is converted to lowercase using the w dot lower. So we then apply the condition w dot is alpha along with this condition here, this exact one, to filter out invalid entries and enforce our word length constraint, which is 5 to 8 letter words. So after we are done filtering it, we remove duplicates explicitly. So this is done using a scene set and a dedupe list, which allows us to preserve the original order whilst ensuring uniqueness in our work. So here in this case, if the dedupe ends up empty, we intentionally raise a runtime error, which translates execution to the except block. And in this case, the except block will call another function within our code called the create fallback words, which I'll be talking about right now. So here, the create fallback words function writes a predefined list of common 5 to 8 letter words directly to a text file we call words.text file, which happens to be this file. So we do that to ensure that the system still produces output even if the word freak library fails. And because anything can happen, you might try importing the words and you might face any error or something. And so yeah, finally the output is written to the words.text file using UTF-8 encoding with a header comment indicating the data source. So this is the source, so word freak top common words 5 to 8 letter words.
So my name is Jordan Wilt Asante Boama, and I'll be explaining the parts of the code that deals with the game initialization and then the data engine. Okay, so this part of the code is responsible for the invisible setup work, which is required for the user to actually play the game. Okay, and this part of the code consists of the dictionary management, the fail-safe safe logic, and then the session research. The dictionary management handles the raw data by reading words, and then the fail-safe logic, it implements a robust safety net, and then the session reset manages the game loop.
My name is Efrifa Richmond, and as for this point of the code, the function determines the color feedback in a Wordle star game by comparing a guess word with the target word and correctly handling repeated letters. The function works in two passes. First, it checks each letter and marks it green if it is in the correct position. At the same time, it counts the remaining letters in the target word. In the second pass, it uses this count to decide whether the remaining letters should be marked yellow or grey. This ensures that no letter is marked more times than it appears in the target word.
And politically, this section acts as the UI construction and layout engine. It is the central hub that assembles the visual interface and connects all the other distinct parts of the code. It consists of the structural layout, the component initialization, and application bootstrapping. The structural layout defines the application's physical or floor plan, where it utilizes a specific split view design where the keyboard is fixed on the left and the game board and controls are stacked on the right. It instantiates every visible control, consisting of the drop-down buttons, switch toggles, and text fields, preparing them for interaction before the game even starts. And the application bootstrapping serves as the launchpad. It acts as a final step in the startup sequence, triggering the data loading, applying the visual themes, and attaching the physical keyboard event listeners to make the game interactive. Thank you.
Yeah, so I'm in person of Saki Clark Eustace. So this section acts as a display controller for your application. It manages visual settings and ensures interface adapts instantly when a user changes preferences. So this consists of the theme management, the visibility control, and the real-time updates. So with the theme management, it handles logic for switching between light and dark bulbs. With the visibility control, it manages the show keyboard state. The real-time update, it bridges the data changes to the visual layer.
The update UI is used to call as a method which is responsible for refreshing the entire user interface when the game state changes. Right, so yes, so that's what the update UI does. So it begins by loading the currently selected theme so that all the colors and styles stay consistent throughout the application. Right, so next we'll be talking about the method. We're talking about the clearing existing content. So it's the method clears all existing UIs from the game board. Right, this method, this line, it clears all the existing UI elements from the game board, the current guest displays, and the on-screen keyboard. Right, so this ensures that the interface is rebuilt clearly without duplicating components. Right, so that's what this is used for. So also then we move to the update game board. So the update game board is also reconstructed after the clearing existing contents happen. So each previous guess is displayed in its own row. Then after that, that's with this lines of code. So after each previous guess is displayed in its own row with the latest colors calculated to indicate correctness. Now an empty row is added to represent the remaining attempt available to the player. Right. Then after that, they add empty rows for remaining attempts. So what this does is The current guest display is updated next. As the player types each entered letter, it appears in its own box, while boxes are shown for letters that haven't been entered yet. Right? So then now the update keyboard. Now the if the on-screen board is enabled, it is rebuilt using a standard QWERTY layout. Each is interactive and controls buttons for backspace and submitting guesses, which are added below on the keyboard. Yes, and also the okay, the add okay, so the add control button. So the buttons are automatically enabled or disabled depending on whether the game has started or is paused or has been ended, ensuring that the player can only interact when appropriate. Then now the update control buttons and the update control. The main control buttons begin. That's the main control button. That's the begin, the pause or the resume, and the end are also updated based on the current game state. That's what this code does. That's the update control buttons and status. Right now, a status is then displayed to the player to guide the player. Now this message changes dynamically to indicate whether the game is waiting to start, right, to be paused, won or lost, and the color updates to match the situation. So there's in every situation there's a color that matches it. You get it, right? So if the game has ended, a play again button becomes visible, allowing the user to restart the game. Right. Finally, the game is updated so that the UI changes are rendered immediately on the screen. Yes. So this is what the update UI does in the game. Thank you.